Hello and welcome to Slew's latest Clubhouse clip. Thanks so much for sticking with us for an extra half an hour of wait. I assure you it will be worth it. This is going to be a very special show. I'm Eric Edelman, the producer, here broadcasting to you live from Washington Depot, Slew HQ. But today, again, we're going to be traveling to the far-off, remote, exotic Canary Islands. This time for a special new adventure here at Slew. We're always expanding. We're always working towards something greater and better, to look toward more objects and to marvel at more opportunities that the universe provides us. And so here we are today. I'm going to be joined today especially by observatory engineer, community manager Paul Cox, who's going to be showing us what happens when a telescope opens its eyes for the first time. And welcome, Paul. Thank you so much for joining me today.
Hi.
You're pretty big on the screen today, and why is that?
Well, hopefully you can see what's behind me. A splendid piece of telescope technology. Sorry, I'm stuttering because I was waiting to see the first image coming in, and yes, we are going to be in luck. I'm just turning that light off because it will affect the images a little bit. But yes, here we are in Dome 2 in the Canary Islands Slough Observatory. And behind me is the new T2 high magnification telescope. It's a plane wave, as you can see, plane wave CDK 17. That's 17 inches. And when we talk about the size of a telescope, we talk about the size of its primary optic. So in this case, the huge mirror that's just behind this case here. So
there's a lot of stuff that's happening tonight, and in particular, at 32 minutes past the hour, just right about now, we're going to be seeing an interesting whale galaxy for the first light of the scope. Like, what is first light? What does that mean? It's a term we've sort of been throwing around a bit today.
Well, first light is really what it says. It's the first time that light hits the telescope, really. And from our point of view, first light is about the first time we go live with missions. And that's what tonight is. Members should start seeing the images coming in. I've got to change something, pointing. Just to point out, this is first light. We are just now entering the operational test phase. So reservations are online, people can schedule the telescope, but we're still testing. And there's something I really want to do before the next mission starts, which is just adjust the pointing a little bit, because I tried to adjust it just before the show, and actually I went the wrong way. But yeah, so that's first light. It's the first time that images hit. There it is. That's the first light image of this telescope. And you can see it's not quite of the Whale Galaxy, because the Whale Galaxy is just off up to the right. But I'm just going to try and sort out the pointing, if you'll excuse me for 30 seconds, Eric, so that we can get the next mission pointing nicely.
Absolutely. This is a whole sort of adventure of starting up this scope and seeing what comes out. We have a fun schedule today that I heard that the members were participating in a little bit, which, you know, at 32 minutes past was the Whale Galaxy, and then at 37 minutes past we have looking forward to be able to look forward to M13. That's coming up, and also 42 minutes past the hour, we're going to get the Dumbbell Nebula. So there's a lot of different things that we're going to be looking at tonight. We can also sort of look forward to seeing what potential lies within this telescope in particular to image, you know, different objects. What is it better for? That's a mystery that we'll solve, that we'll ask about, because, you know, that's one of the great things about having multiple telescopes in your network, is that you can go from multiple locations and you can have specialist telescopes for different objects. I hope a lot of you have enjoyed our meteor shower cam as well. Lots of things to be adding. But yeah,
I am back, Eric, by the way.
Well, yeah. How did the pointing experiment go, Paul?
Well, what's happened today is the reason why we were late. Is I needed to do one last what's called collimation, and collimation is aligning all of the optics in a telescope system. Actually, let me just show you the telescope, because it's moving at the moment to the next object. I'll
it's
switch
not
the
only
light
moving,
out again.
it's slewing.
So back here, you can see the camera. This is the camera. This is the filter wheel. In here, all of this space is taken up by this enormous focuser. And I had to remove all of this evening to put on another piece of equipment, which looks like this. Hopefully you can see that. So I had to put this thing on the back of the telescope, and this has a little raunchy grating on the back of it. And this whole thing is manufactured to be an exact distance within microns, you know, a thousandth of an inch. And it's to make sure that the telescope optics are properly spaced. So in this instance, on this particular type of telescope, we've got the big mirror at the back, which is the primary mirror. We've got the smaller mirror at the front, which is actually the same size as most people's private telescope. The secondary mirror on this thing is so enormous. You know, it's about this size, must be 8 inches, I think, something like that. And they have to be spaced. The space between them has to be within 1 millimeter, preferably 0.5 millimeter. And you can't measure that properly, but that little device I just showed you there, that allows you to fix that spacing very, very accurately. And then after that, I had to do what's called collimation, which is adjusting the angle that the secondary mirror is at, so that it directly puts everything back down into the camera in exactly the way that it should. So it's not skewed off or anything like that, because that kind of gives you fuzzy images. So that's why we were late. I put everything back together and ran a first test, and suddenly the focuser decided it wanted to move to a different position. So, you know, we've had first light. That's it. You know, we're working now on refining absolutely everything for this. We're going to be refining. The pointing was good, actually, until I removed all of the equipment, but even removing equipment like that and putting it back on can affect the pointing. I've also put on a shroud today, which will help us with moonlight and also keep dust out of the telescope as well. So that's what we've been up to today, as well as tidying up. And we've got the next image coming in, and it's a corker. It's an absolute corker.
There's
So,
so much that has been happening that you've been preparing for. Like, how long does it take to get a telescope of this magnitude ready for service, ready for light?
well, on its own, not very long. But what we've been doing here is I've revamped just about every single system that we've had here. We've had a change of PCs. Some of the PCs were getting a little bit old, so we want to replace those before they fail. And you know, this is a very different observatory to most observatories. It's totally unmanned for the entire year. So the way we have to set things up here, it has to be incredibly robust. So I've taken out an old 120 volt power circuit and transformer that kept tripping the electrics here. I've redone some of the network cabling. We had a network switch fail. So there's lots of things other than just the telescope. But on this visit, it's really just been the commissioning of it, because it was set up, if you remember, earlier on in the year, in I think it was it February or March, and the problem is the day it was ready for commissioning, the dome failed. We were taking some photos of the dome, and then bang, it just failed. So that wasn't good news. So then we had to wait for the dome parts to come through, and yeah, so commissioning over this last week or so has gone fairly straightforwardly. We did, by the way, move the pier as well. We wanted to try 2 positions here, and that took a few days to do that, just so that we can get the telescope in the most sheltered position possible, but without it we're still being able to have a good horizon. So
And
that's some of the work. And then last week we did have a problem with the mount. We thought it was a catastrophic failure of the mount, and we didn't share it because we didn't want to upset people. But it took 3 days, all weekend, to figure out what had gone wrong with that. And it was a tiny, tiny sensor. There's a photo in the clubhouse of it, a tiny sensor that had just come off. And it took 3 days just to work basically up from the mount, from the bottom of the mount up, to try and find that problem. So now, Eric, that image that you're showing there, you've zoomed in quite a lot there, so it's making it a little bit blurrier than the original is. But if members are watching at the moment, they can also see that in the MI, which is a slightly nicer image of M13.
so about M13, I mean, what would be the difference between taking an image here with T2 versus T1?
Well, 2 things really. The first one is going to be higher resolution, because the new camera that we've got in here, the T2 camera, is about 1,000 pixels, I believe it is, that's from memory, about 1,000 pixels greater than the T1 camera. We've also got 5-minute missions still in T2, so that's going to be hopefully most members are going to enjoy that, because it means that the quota of the number of missions every night from TEDI is going to be the same. And in fact, if T2 works out, we have got a couple of timing issues. Some missions, they do time out, so they don't go to color. But if it works out and we can get that working, we'll probably do the same thing on T1. But the other thing you'll notice on that M13 image is we're seeing far more sky. The field of view here is a lot bigger. It's 43 arc minutes. So an arc minute is a 60th of a degree. So that's those are the core benefits. And we've got this next image coming in, and actually this is, I popped this one in. Peter, do excuse me, because we missed our first light missions. You were the first person up, so in fact you had first light on this. It's Peter Eilis. And I did nick your last image that was just to a star, because I wanted to show this. This is M27, the Dumbbell Nebula. And I wanted to show this because it gives that sense of scale, Eric. You know, people are familiar with seeing this in T1 images, and we can see a lot more stars around it. And I did some test images of this particular object last week, and members are going to be really pleased. You can see a couple of things as well, by the way, Eric, at the moment, but that's still M13. M27 is going to come through in a sec. You'll see some vignetting. Vignetting is this kind of darkening around the edge of the image, and that's because we haven't made the flat fields yet. It was pointless making flat fields. Sorry, let me explain what flat fields do. You take an image with this highly sensitive camera in twilight skies, roughly overhead, which has a very, very even illumination. And what you're trying to capture there is the vignetting. So this is any shadowing or any constriction of the image by the telescope system or the filters. Gone.
By the way, we're seeing just this this beautiful transition into a new live image that I think just is gorgeous and showing sort of what this telescope can do. Absolutely.
And when you see these images, Eric, in comparison to what T1 does in 10 minutes, then I think it's going to land up knocking people's socks off. You know, this is a fabulous, fabulous telescope, and when we fine tune it, it's really going to be performing well. I'm seeing things slightly before you are, so I'm still seeing this vignetting. But anyway, so we've got that to do. So the vignetting will disappear, any dust donuts will disappear. The images will lose a lot of noise. We haven't done hot pixel maps yet, so we might see some hot pixels. There's all sorts of things. This is, although we're going live now, this is live operational testing. This is what we need to do to really rattle this telescope down to see if there are any problems with it.
It's really, I mean, it's amazing to see this process in motion here. And we actually have a question that came in the clubhouse. People are very interested to see the potential for this telescope. This is coming in from Dougal. Thank you, Dougal, for your question. We talked a little bit about it, like what's the differences, what's the advantages for this telescope over another, and maybe what particular celestial objects are best suited for this one. You know, such as, you know, would it be globular clusters? Would it be planets? What would it be?
Large. It's a little bit of a sarcastic answer, but it's true. The field of view on this instrument is very big, and it's really going to suit those large objects which are quite faint and quite fuzzy normally. So galaxies, the best suited for this is going to be nebulae. Things like the Rosette Nebula is going to be fantastic. And one difference on this particular camera in comparison to the old T2 camera is that this is square format. So the images are square in the same way that T1's images are square. And I actually quite like that format. It frames up most things well. You know, if you think about most objects that we see in the night sky, they're kind of symmetrical. So that square format really helps. But, and this is a big but, I also ran some tests on Jupiter and Saturn with this. And I think members are going to be quite surprised at how we can get one telescope giving us these gorgeous images of these huge nebulae like the Rosette, but also then going down to the tiniest objects in the sky that we can see, Jupiter and Saturn. So I think we're going to have to do some work on that, but the first looks were really quite encouraging.
And I think we'll get some great advice on, of course, the infamous "What's Up This Week" post section in the clubhouse.
Look at that! Look at that!
Ooh,
That's the one.
Look at that color.
That is a 5-minute mission. Now, if you compare that to T1's 10-minute missions, you know, I think most members are going to want double the number of reservation slots for T1 rather than having a slightly deeper image. And that's not showing up very well on my screen through Skype, Eric, but the original image of that is looking absolutely cracking. It really is. So yeah, these are very encouraging first views from T2.
Absolutely, wow. And yeah, there's 5-minute missions is a great sort of way to have a lot more free spots for people to really explore this telescope. And so,
Yeah.
yeah, do you have any maybe recommendations for the next week or so in terms of what we should be looking at, what we should be trying out as a community to test this new telescope?
Well, one of the problems, of course, is that it's full moon this week. So I believe that's tomorrow. I have given some recommendations in What's Up This Week, which take account of the moon. And there's some great ones in there. Globular clusters, of course, are always great. And they're going to look great in this telescope when we fine tune it. Some of the colors of those dark blue straggler stars in those globular clusters is the color coming from this is just so rich. And part of that, Eric, is there's two parts of that actually. One is the camera. Each different CCD chip has different color responses. But we've also got a new set of filters in here. They're some of the best filters in the world. They're Astrodon. They're kind of Mark II research grade filters. And we're going to have to do a little bit of color balancing and stuff like that. But we can't do that work when we're under the moon. You know, you'll see tonight when missions carry on running tonight that a lot of the images have a slight blue tinge. Well, that's because of the moonlight. And we haven't, if I try to do color balance now, measure the color balance to each filter, it would look absolutely horrible as soon as the moon disappeared. So we'll have to wait next week for that. But I would say this week, the end of this week, all of the core things will be done and run through with this telescope, and maybe just a few straggling things in the following week, such as color balance, when we can do that when there's no moon.
So we're really pretty close. And wow, what are we looking at now? What's just coming into view here?
This is the gorgeous Black Eye Galaxy.
Ooh.
An absolute stunner. I think this is Peter's mission as well. So, Peter, you got the first, what, 3, 4 missions tonight, which is absolutely great because we started a little bit late. But, you know, once again, one of the other things that people will notice, the difference here, Eric, between this and the old system is we've got a brand new mount in here, the telescope mount. This is a really, really big, beefy mount, more than capable of carrying this 17-inch telescope. And while it slews, maybe I can show you, we haven't got the T2 wide field operating at the moment, but there it is. It's all mounted. I've just got to do a focus calibration on that, and we'll have wide field images as well. And actually, that's an important thing to mention. Just while I show you these images while the telescope slews, which is great, because this is Peter, right? This is Peter controlling this telescope, and this is the amazing part of slew. Peter's done this from his home. He set up this mission, right? The next one is to actually this next mission is the Fireworks Galaxy. I'm going to switch the light off again. And that telescope has moved because a member has told it to move and where to move. But let me talk about the wide field very quickly, Eric. I know we're running out of time, but it's a great opportunity, a good one-off opportunity to tell members some of this stuff. We have a new camera on the wide field system, and the main difference that makes is, one, it's more sensitive. It's a more sensitive camera, so we'll get deeper images. So we'll get more of that faint detail that the T2 wide field telescope is so good at picking out for such a tiny, tiny telescope. But it's also a larger CCD. And if you put a larger CCD chip on the same telescope, then you land up with a wider field of view. So what we've done is we've increased the T2 wide field even more to kind of compensate, so it's not so close to the 17-inch huge field of view. So we are going to see some absolute treats from that new T2 wide field system when that comes online in a couple of nights' time. I know people like Keith Smith are going to absolutely love working with that new wider field. He does a huge number of mosaics of very, very large objects spread out over the sky. So the larger field of view that you can get in a single image, the less panels you have to make to piece your mosaic jigsaw together.
There's so much going on here. It's so great. And really, call out to Slew members here in that if there's something that you want to see in the night sky that you think that we can, work towards, that we can develop, that we don't have here, let us know. And we're always working towards expanding and creating a better experience here for you with these telescopes, with these live shows. And I mean, you just Paul Cox is over there working tirelessly on all this stuff. A big thank you to you for all you've done so far here on this stuff. Really, Paul, thank you.
Well, that's right. I'm off home tomorrow. I've forgotten what home is like, because obviously we were here also for the 3-week project of the Vodafone Moon, so that took up a lot of our time here. We couldn't do anything because we were waiting for dome parts and stuff like that. But yeah, so it feels like I haven't been home for a long time. But everything else to do on this system, to get it fully ready and fully honed down, can all be done remotely. So we may interrupt operations from time to time, but it won't be for long. But in the meantime, let's have a look at the schedule. Is the schedule booked for tonight? Yep, people have fully booked the T2 system. So it is going to be online all night. Please, folks, bear with us. We are in this testing phase. There is some vignetting. Focus may not be perfect. Pointing may not be perfect, but this is giving you the flavor of what we've got to look forward to. And I'll tell you, Eric, since I've been here working on this telescope system, the mount, the new camera, the new filter wheel, the actual telescope itself, these are wonderful, wonderful bits of technology to work on. I mean, they're fun, they're enjoyable, they work, they're easy to work on. And all of the way through, I've just been thinking, members are going to love this. This is going to be so different in comparison to the old 2T system, which was brilliant for things like planets. But don't forget, we had the mounts, was, trailing stars every now and again. It was tired. It needed replacement, and that's what we've done. But we have got some other ideas as well coming up for planets as well. But in the meantime, I think you'll enjoy and be quite surprised at what a 17-inch telescope can actually do on an incredibly bright object like Jupiter or Saturn.
Yeah, let's say it here right now. Let's slew
Ooh,
members, slew
Fireworks
community.
Galaxy, by the way.
Sorry, what?
Fireworks Galaxy. That's what's up at
Ooh.
the moment.
Yeah, I was just looking at this, just gorgeous spirals. It's, gaze at
It
this
is.
stuff because it'll be coming around all the time. This is what you have to look forward to. Test the limits of the scope and just go as far as you possibly can. That's what we're here to do. But as we talk about all this amazing opportunity that we have here now, do you have any sort of final thoughts that you'd like to say? Put a bow on this topic, so to speak. What can we sort of really expect from this T2?
Amazing things in 5-minute missions. This telescope is. I don't think it's underselling it to say that this is going to revolutionize what SLU members can do. We've got over 100 missions a night, up to about 140 during the winter on this telescope, and it's really good at doing a lot of things. So it's also good for all of the researchers as well. So if you're looking for faint and fuzzy comets or near-Earth asteroids, then this is going to be a superb system. None of that trailing from the old T2 system that used to really make that difficult work for people doing real science.
Yeah, whether whatever you happen to be doing with this scope, and we can see this galaxy come into color here right now. Oh gosh, it's just 5-minute missions can do that. That is fantastic.
And this is a very, very faint galaxy. The Fireworks Galaxy is an incredibly difficult one to image because it's very, very faint. So if we can pick that up in a 5-minute mission, imagine what it's going to do with things like the Whirlpool. And actually, some of the things that I've seen, we've got the Whirlpool Galaxy scheduled by members. We've got more globular clusters. There's a whole stack, Eric. You've just got to stay glued, basically, for the entire night to T2.
Oh, geez. Yeah. From what I'm hearing, we just have a plethora of stuff available to people that are citizen astronomers that are using these scopes. And also, never fear. community members, because this will also open the door to so many more shows. There's so much more we can do with shows, and the views
Yeah.
that we can show you in the shows, if I haven't said shows enough. So I, I really hope you've enjoyed this sort of introductory taste to what we have to expect from T2. And there's going to be a lot coming from members and from our shows in just the near future. So that's really great. And thank you so much for talking this over with me, Paul. I think everybody was really psyched to get a first look, a first light into T2. And I think that came off really well tonight.
A pleasure. And I have released the remaining editor slots tonight, so there are more slots available for later on as we watch this incredible image coming in of the Veil Nebula. This showcases what this instrument can do, Eric. It's a faint, large object. So we should leave members to watch that on their own in the mission interface when that goes to color.
Absolutely. Yeah, that's just stare at the mission interface for the rest of the night. That's my recommendation to you, because you have a lot to look forward to. And we're going to be back with shows in no time. Look forward to Pluto coming to the clubhouse in just a couple days, because New Horizons is inching closer and closer, and we want to see what's just going on over there. But for now, just for a short time, we're going to be going away. But this has been Eric and Paul for SLU. We'll see you again. Live from Washington Depot, SLU HQ. And but today again we're going to be traveling to the far off, remote, exotic Canary Islands. This time for a special new adventure here at SLU. We're always expanding, we're always working towards something greater and better, to look toward more objects and to marvel at more opportunities that the universe provides us. And so here we are today. I'm going to be joined today especially by observatory engineer, community manager Paul Cox, who's going to be showing us what happens when a telescope opens its eyes for the first time. And welcome, Paul. Thank you so much for joining me today.
Hi.
You're pretty big on the screen today, and why is that?
Well, hopefully you can see what's behind me. A splendid piece of telescope technology. Sorry, I'm stuttering because I was waiting to see the first image coming in, and yes, we are going to be in luck. I'm just turning that light off because it will affect the images a little bit. But yes, here we are in Dome 2 in the Canary Islands Slough Observatory. And behind me is the new T2 high magnification telescope. It's a plane wave, as you can see, plane wave CDK 17. And that's 17 inches. And when we talk about the size of a telescope, we talk about the size of its primary optic. So in this case, the huge mirror that's just behind this case here. So
There's a lot of stuff that's happening tonight, and in particular, at 32 minutes past the hour, just right about now, we're going to be seeing an interesting whale galaxy for the first light. Hello and welcome to Slew's latest Clubhouse clip. Thanks so much for sticking with us for an extra half an hour of wait. I assure you it will be worth it. This is going to be a very special show. I'm Eric Edelman, the producer, here broadcasting to you